Well, I called tech support and they told me to unplug the router and plug it back in. And well, as you can see, I unplugged the router and I plugged it back in, but it hasn't really done anything. So I think this router is broken. Well, I think this is the router. Maybe the router is this thing. Which one's the router? Hell, what is any of this stuff anyway? As we start using more and more sophisticated computing devices in our homes and small offices, we need to think about the networking devices that are used to connect those computers, those iPods, those printers, and everything else to each other and to the internet. Networking devices are often overlooked things on the computer network that people just don't think about very much. This here is a Cisco router. This is approximately a $500 device. It doesn't look cool, it doesn't look complicated, there's no holographs on here, there's no GPU numbers or CPU numbers. But this device does networking very well. It allows computers on the internal network to talk to each other and then get out on the internet, and it does it, like I say, very, very well. This is the top of the line product. Today we're going to go over the devices that you will find in the average small network. So whether you're a residential client, you're a small business, you will have these devices, and these devices will be what allow your computers to talk to each other and then again get on the internet. So this is an introduction to networking class, and we're going to go over the hardware and the basic requirements to make your computers talk. Now the first thing that I'm going to talk about is I'm going to show you a basic diagram of how your network connects together and where the different components fit in. So the first thing that we need to talk about is the internet cloud. So the internet cloud, for all intents and purposes, is the internet. So everything that you think of that is on the internet, whether it's websites, whether it's virtual private network connections, whether it's email, anything that you associate with the internet resides in the internet cloud. So if you hear internet cloud or cloud, that is the internet. The reason we call it the cloud is the internet is an insanely sophisticated system of networks, and nobody really understands how it works. It's very complicated. You can go on days and days and days and days in class on how the internet works. So instead of going into all that, we just call it the internet cloud. So if you hear of the internet cloud or like cloud computing or any of that, all that means is that the cloud is the internet. So if you're dealing with a cloud application, that means that application is within the internet. So internet equals cloud, cloud equals internet. Now the first device then that will be on your network, the very first device that will connect your computers to the internet will be your modem. So your modem is the first device that you own, that's part of your equipment that will connect you to the internet. Now behind that will be something called a router. So this is another device that you will own, that you will have, and the router then connects to the modem. Underneath your router, you will have something called a firewall. A firewall is a protective device that tries to protect your network from hackers. So that will be underneath the router. Underneath then the firewall will be something called the switch. The switch, you can think of the switch as a splitter of the internet signal. So you can, we'll go into this in class, you can have however many computers connected that you want, but all of your computers or devices will connect into the switch, and then the switch will then either allow them to communicate with each other or to go out onto the internet. Another device that will be on your network is, of course, a wireless access point. The wireless access point will allow wireless computers and devices to then connect to the network. So they will connect to the wireless access point, which connects to the switch, and then they can communicate either to other devices on the network or to the internet. So basically you'll have your computer, That goes to a switch, that goes through a firewall, that goes through a router, that goes through a modem, and then you get to the internet. So this seems like a lot of stuff. It gets easier, but this is the overall concept and diagram about how your network looks. Before we go any further, I want to go over two concepts that always confuse everybody and it just makes everybody really frustrated. So if we go over those concepts now, hopefully you'll be less frustrated later. Probably not, but you may be. The first things we're going to go over are, we're going to talk about speed and what it means, and then the difference between something called physical and logical. So let's go over the concepts of physical and logical first. Within the computer world, we talk about let's say like computer devices and how they connect to each other in the physical way and then in the logical way. And what you need to understand is that these two things are not necessarily the same thing and many times are very, very, very different. So the physical way that computers connect are, let's say you have a computer and then you have a network cable, and that network cable physically runs all the way back to a switch somewhere. And that switch is physically connected to a router. And that router is physically connected to something else, which is connected to something else. So that computer is physically connected to the switch, which is connected to the router, etc. Well, within the computer world, we can also split things up logically. So let's say you have 20 computers and they're all connected to the same switch. Well, they are physically all connected to the same switch. But what we can do in the computer world is within that switch, we can put, let's say, we can split those computers down the middle and put half of the computers, 10 of the computers, logically onto one network and the other half logically onto another network. So although the computers physically come together, they connect into that one switch, logically, they're not able to talk to each other because it's split in that switch. So when we do diagramming, we'll split everything out like I showed you, the internet cloud, the modem, the router, the firewall, the switch, and that is logically what happens. Those are logically all the different devices that are used. But now that we can cram a whole bunch of stuff into one little device, you will find, or you normally will find, all of those logical devices are contained within one physical device. So the modem, the router, the firewall, the wireless access point, and the switch are physically now one device. Now when we talk about it in computer lingo, they are all different devices. They are logically different devices, but they've all been built into one device, so now they are one physical device. So it's hard to get a lot of people, for them to get their head around, but just remember that logical and physical are not necessarily the same thing. So although you plug your computer into the same switch that everybody else is connected to, you may not logically be part of that network and you may not be able to communicate with the other computers on that network. The next thing we need to talk about is speed. Speed is ridiculous. What you should know that is data is sized by two different types of measurement. You can either have something called bits or you can have bytes. So bits are signified by a lowercase b. Bytes are signified by an uppercase b. So a kilobit would be K lowercase b. A kilobyte would be K uppercase b. What's important is those two words sound very similar. But it takes 8 bits to equal 1 byte. So 8b equals 1 big B. So 8 little bits equals 1 big byte. Now, in the normal world, when you were talking about storage, when you were talking about how much data a hard drive can hold, or a flash drive can hold, or a CD can hold, you're talking about bytes. So it'll say megabytes or now gigabytes. So you'll see a hard drive that has 500 MB, megabytes of storage. Well, what the internet vendors do, the Comcasts, the Verizons, the Quests of the world, they kind of mess with you because they know that you're going to get confused. When you buy internet service, they tell you the speed in bits. So if you have, let's say you're with Comcast, and you have a, let me clear this off for a second. And you can download 12 megabit per second. So that's 12 big M little b, right? That's less than 2 megabytes. I think it's, it's 1.5 megabytes because 8 bits are in a byte. So if you're looking at a hard drive and you're thinking, I want to upload 100 megabytes, it's going to take 8 times as long as you're thinking because it takes 8 bits to make a byte. So that's something that a lot of people get confused about, but just keep that in the back of your head when you're dealing with the internet or you're transferring large amounts of data over the internet, is the internet vendors tell you their speeds in bits, data storage is in bytes, and so it takes 8 bits to make 1 byte. We're now going to talk about the first device that connects your network to the internet. This device is called a modem. So your modem can be for either a T1 connection, it can be for a cable connection, it can be for DSL, or it can even be for a satellite internet connection. Any of these types of internet connections require a modem to connect your network to the internet. Basically what the modem does is it turns your Ethernet signal, it turns the protocol, the language that you use on your internal network into the language that can be used on the internet. So let's say back in the day when you had the old type modem in your computer, you used to hear that. Well, that sound was turning your data transmission, it was turning your email or whatever you were trying to do into a signal that the telephone company could use. So it turned the data into an audio signal. The basic concept is true today. So if you have a network that uses a DSL modem, the DSL modem, what happens is all the communications that are going out to the internet hit that DSL modem. The DSL modem then turns that network communication into a language that Verizon or whatever your telephone company will understand, and then that's how it gets on the internet. So the modem is the connector between the internet and your network. Like I say, there's a few types of different modems out there. If you have a T1 connection, you are most likely going to be using a device called an ADTRAN, A-D-T-R-A-N. This is something called a CSU, DSU. They're not used a lot anymore just because T1s are very expensive, but they're there. T1s are the best overall type of connection to the internet, but they are insanely expensive. And today they're not very fast. You can get something called T2s and T3s. These are higher level T1s, but they start getting stupidly expensive. Even now, in 2009, a T1 connection, which is only 1.5 megs per second, is about $400 to $500. Compare that to Comcast internet, where for $200 a month, you can get 50 meg down, 20 meg up, or Verizon Fios, I think, is the same for about $150 a month. So the cost difference between a T1 line and either Fios or DSL or Comcast is huge. But T1 lines do go farther, so a lot of times if you cannot get DSL service in your area, or you cannot get cable internet or any of that, a lot of times you will be able to get a T1 connection, but just realize it's going to be a lot more expensive. The next type of connection is a DSL connection, digital subscriber line. These are provided by your phone company. So if you're with Verizon or Quest or any of the other phone companies out there, they will offer you a DSL connection. DSL signals are generally very good, and they've come down in price. So here in Baltimore, for about $15 a month, you can get 756K upload speed or download speed. So it's not incredibly fast, but it's fast enough for a lot of users. What you should remember with DSL is DSL's maximum speed is somewhere around 12 megabit per second. It will never get faster than that. It's a problem, or it's a limitation of the technology. So Comcast is always getting faster, or cable modems are getting faster, fiber optic modems are getting faster. DSL will never be faster than 12 megabits per second. It's just a technological problem. The nice part with DSL is that you have a solid connection between your modem and the central office and the telephone office where you connect to the internet. Unlike some of the other types of internet connections that share the bandwidth to a central place that gets on the internet, you have a dedicated line between your house and Verizon. So it doesn't matter if 100 people get on the internet or 1 million people get on the internet at the exact same time you do, you will never see a reduction in service. You know, your speed will not go down because all of your neighbors got on the internet at the same time. That's one of the good parts with DSL. You should remember DSL is asynchronous data transfer. What this means is you can download faster than you can upload. So with DSL in our area, you never are able to upload any more than 756 kilobits per second. So it's just something to think about. Most people, this doesn't matter unless you have a web server, or if you're a business, this may matter if people are using something called VPN to get into your network, because then you will need to send data out to the internet, so this may be a problem. So just remember, you may have 8 megabits per second download speed, but your upload speed will probably be only 756 kilobits per second. The next type of connection is cable modem. Cable modems have come a long way in the past 8 or 10 years. They now are a lot more solid, a lot more stable. There's a lot fewer problems using cable internet nowadays. Cable internet has introduced new technology called DOCSIS 3.0 that, when it is fully implemented, will allow for 160 megabit per second download speed, and I think it's 80 megabit per second upload speed. So technology that already exists, has already been proven, can give you speeds of up to 160 megabits per second download, and like I say, about 80 up. At this point, the cable companies are simply implementing it. You know, it's just a cost thing. It already exists. They already know they can do it. It's not a huge issue doing it. They just need enough money to do it. The thing with the cable connections is, unlike the DSL, you do have to share the main bandwidth that goes back to the internet. So in some areas, if a lot of people get on the internet at the exact same time, you can notice a massive reduction in speed. So some days on my connection, I get up to 20 megabits per second download speed, and other days I only get 8 megabits per second download speed. The reason is the more people that are sharing that internet connection, the slower your access to the internet may be. There is also satellite internet out there. Not a lot of people use this. This is good if you're just out in the middle of nowhere, because you can literally be in the middle of a desert and you can get satellite internet. The problem is the download speed isn't too bad. It's about 1.5 megabits per second, but the upload speed is absolutely atrocious. You cannot do any type of real-time communication. You can't do voice over IP. You can't do anything like remote desktop. You can't do anything that requires communication back and forth over the internet connection. But if all you need to do is be able to get to web pages and download things off the internet, satellite is out there. They also have new wireless services. The 4G networks you may have heard of from Sprint and now from Verizon. These are starting to come into their own. Basically with these is you get a little wireless device that connects to the cell towers of either Verizon or Sprint or whatever cell phone company in your area is providing the service. So it's just like if you had DSL or cable modem, you hook one of these wireless modems into your network, and then your network then connects to the internet through that wireless modem. This is still a relatively new commercial technology, so I can't go into it a lot because it hasn't really been tried and true, tested in the real world. But it is a possibility if you're having issues running wiring and such, you may use one of these wireless modems to connect your network out to the internet. So now that we understand modems, the next device that is underneath a modem in your average network is something called a router. So what the router does is the router allows you to separate different networks. So let's say you're in a building and you're sharing the internet connection between multiple different businesses in one building. So sometimes you may become a tenant of a building and they offer you internet connection as part of the service. Well, all of the tenants within the building may be sharing the same internet connection, so they need some way to separate the different tenants onto their own private networks, because you don't want tenants hacking each other. You don't want it all completely open. So in that scenario, what would happen is your internet connection would be split out from the modem, and that would go to different routers for the different tenants within the building. So every tenant would have their own router. So what this allows to happen is each tenant, no matter how many computers they have on their own internal network, can go out through the router and go into the internet. But they cannot get into one of the other people's internal networks. So you can go out through the router, but you would not be able to loop and get back in and be able to hack anybody else's network. So routers are used logically to divide networks. And this, again, is used normally for internet connections. If you want to use only one internet connection, but provide that internet connection to multiple users or multiple tenants on the network, basically you would have one internet connection and then multiple routers connected. So all of those networks can then connect to the internet without having to worry about anybody hacking them. Now, underneath your router, you normally have the firewall. A firewall is a device that tries to prevent hackers from being able to get into your network through the internet. Firewalls are part of their own class. They're part of a security function, and nowadays especially they get very, very complicated. Back in the old days, they were their own standalone devices. So underneath the router, you would have a firewall, and the firewall would try to prevent internet traffic that you didn't want to have happen. So if you didn't want anybody to get in from the outside world, you would use a firewall and you would block, like I say, hackers from trying to get into your internal network from the outside world. Nowadays, firewalls have become much more complicated, and you can't just say that they're underneath the router. There's software firewalls that are now built into each individual computer. There are intrusion protection systems where you have entire servers that run a network of firewalls within your network. So firewalls now are much more complicated than just a simple box thrown on the network. But firewalls are a security device. If you have a firewall, nowadays it will be built into either your modem or into your router. What you should remember is that if it is built into your modem or your router and you turn the firewall on, if you're using the firewall within the modem or router, it will block internet services for the entire network. So if you don't want people to be able to get on to websites for some reason, they use something called port 80. So if you block port 80 in the firewall built into either the router or the modem, then nobody on the entire network will be able to get to a website. So firewalls are security devices. If you use the one that is built into either your modem or router, remember that it will affect the entire network and may have some unintended consequences. So, but again, this is part of a different class, and so we'll talk about this more later. So speaking about firewalls and keeping hackers and people that you want out of your network from getting into your network from the internet, you may also need people from outside of your office to be able to get onto your local network. Most people use something called a VPN to do this, a virtual private network. What this allows is it allows computers that are anywhere in the world to connect to your internal network. And as far as the computers and the networking devices are concerned, that computer is now inside your network. So if somebody is sitting in China and wants to print to your printer in Milwaukee, they can connect to your network using VPN, a virtual private network, and then hit the print button and something will print out in the office in Milwaukee. So somebody on a VPN can connect to all the shared files, shared folders, shared printers, any resources that are shared on the internal network they will be able to access. The one thing to keep in mind though is they will be able to access it, but a lot more slowly, because your internal network works at least 100 megabits per second, which is pretty fast. So, but the person on the outside world, remember, they have to go through the internet. So depending on what their internet speed is and what your internet speed is and any problems going on in the internet right at that moment, things can take a while. Things can get very slow. So like in my business, I used to try to use QuickBooks through VPN, through a virtual private network. It was just too big, it was too complicated of a program to work properly. I could connect to it, I could log in, but the amount of data that needed to be transferred back and forth was just ridiculous. So the VPN allows somebody from the outside world to connect to your internal network. It does this through what's called a client-server architecture. So you have a server inside your network. This is a logical server. It's called a VPN endpoint. So this endpoint has things like usernames and passwords of the people that are allowed to connect to the network using the VPN, virtual private network. Then the client computer, you normally install a little client application that can connect to that VPN endpoint. You give that client application some information, including your username and password. It will then connect to the VPN endpoint. It'll authenticate. And then as long as everything's okay, that VPN endpoint will then allow the computer to be on the network. So you have the client connects to the endpoint, that gets you on the network. Why I now say that the VPN endpoint is a logical server is, again, back in the days, there used to be things called radius servers, or servers that all they did was allow people remote access to the network. Now, for the most part, this type of server service is built into another device. So if you have a Windows server that has this service built into it, you can simply turn it on. You do not need an additional device to make this happen. Many of the commercial routers that you buy have this service built into them. So they have a VPN service already built into them. And if you go through the configuration routine, you can use that. You don't have to buy another device, another widget. So virtual private network allows people in the outside world to connect to your internal network, and it does so very securely. So now, after you have your modem, you have your router, you have your firewall, you have some of the other stuff that we've talked about. Now you come to the device that connects all of the devices on the network together to allow them to talk to each other. This device is either called a hub or a switch. Hubs and switches are two different things. If you have a hub on your network, you need to pull it out and you need to throw it in the trash. Hubs are completely and utterly obsolete. They were obsolete a decade ago. They were obsolete back in 2000. If you still have one and you're having networking problems, if your network is slow, it's probably because you have a hub. To see whether you have a hub or a switch, you just look on the front of it or on the top, and it'll tell you somewhere whether it's a hub or a switch. So on this switch, if you can see, if it autofocuses, see it's a gigabit switch. So a switch is something that you want. A hub is not. The difference between a hub and a switch is a hub is dumb. It has no intelligence whatsoever. A switch has a little bit of intelligence, and that little bit of intelligence makes a world of difference. Hubs basically split the internet signal or the network signal to everybody equally. It is literally like a complicated cable splitter. So you know, you have a cable wire coming into your house, you plug it into a splitter with 3, 4, or 8 different connections, and that runs to 3, 4, 8 different TVs in your house. That is what a hub does for computers. The problem is, this will go into another class because it gets complicated about how Ethernet and TCP, IP, and all of that work. The thing is, that's completely dumb, and that causes problems. Now, switches are smart. They understand how to transfer data properly so that the network runs efficiently. So basically what you really just need to know is if you have a hub, you need to throw it out. You want a switch. If you want more information, we'll have a class on it. So all of the devices, all the wired devices, everything with a network cable, at some point comes into your switch now. As you will see on the back of a switch, it has ports. Basically the ports, all the computers plug into these ports. One of these ports goes to your router. That's what connects everything together. Switches can have as few as 4 ports. The average small business, somebody probably like you, what I have in my shop, you can get switches with up to 48 ports. So these are single devices. They're about yay big, and they can connect up to 48 computers. If you're in really big enterprise, large company environments, they have switches that will, just hundreds or 1,000 users, but those cost $100,000 or more, so I don't think you're going to be using those anytime soon. So all of the connections to the computers and devices come into the switch, and that's how they all talk. You will hear about what are called managed and unmanaged switches. So, as I told you, hubs are completely dumb. They have no brain power. They're just there. They're just splitters. The next level up is an unmanaged switch. So an unmanaged switch has a little bit of brain power, but everything is absolutely automatic in it. So you can't configure anything inside, like this switch. You cannot configure anything. You have to hope and pray that it's doing what it's supposed to do. The next level up is something called a managed switch. This gets complicated, but like when you're dealing with buildings or businesses that may be using 48 different computers, the managed switch allows you to go into the switch and program the switch to do certain things. Again, this gets complicated. We'll go into a different class. But basically, the managed switch allows you to tune the network to make it work properly. It allows you to play with things like quality of service and other high-level networking stuff that you don't need to know about right now. But basically, the managed switch allows you to play and to change settings in the switch. Unmanaged switches don't allow you to do that. So the switch is what allows everything to connect together. You as a small business or person will see switches either 4-port all the way up to about 48-port. They do have larger switches, but again, you probably will not see them because then you're talking about $100,000. You will notice on the new switches, it will say speed. So there we go. This one is 10, 100, 1000. So this is a gigabit connection. Networking has 3 speeds right now. They had the 10 megabit connection speed. This was about 20 years old at this point. Then they had the 100 megabit connection speed. This is the speed that almost all networks run off of. It's been the standard, or it was the standard for at least 10 years. And now they have the gigabit networking speed, which is 1,000 megabits per second. This is the latest standard. but your switch needs to be able to support the speed. So if you want the fastest communication between all your computers on the network, then you need to make sure your computer is capable of gigabit networking, and then that your switch is capable of gigabit networking. A lot of people now are buying these computers with really fast networking cards in them, but then connecting them to the old switches, and therefore the speed of the switch will never be able to match the speed of the computer, so it will always be slower than it could be. Now that you have all of your wired devices talking to each other, all of the computers on your network now talk to each other and then go out on the internet, now you need to deal with your wireless devices, whether they're wireless printers, whether they're your little iPhone or laptop computers. Those devices now need to be able to communicate with everything else on the network. They do this through something called a wireless access point. All a wireless access point is it is a device that allows wireless computers and devices to connect to the network. So it's a device usually about this big. Some of them have little antennas on them, some of them do not. It doesn't really matter as long as they're wireless access points. So those wireless access points, all the computers wirelessly connect to them, and then they will have one cable that goes from that wireless access point into the switch. And so that is how all of the wireless devices can then communicate with the wired devices, and the wired devices can communicate with the wireless device through the wireless access point. You will hear about 4 standards for wireless access points. The first part of the standard is something called 802.11. This is just the number of the standard. You will then hear about A, B, G, and N. So 802.11b, 802.11g, 802.11n. 802.11a was a very fast, very good standard that was pushed by Intel a few years ago, and it flopped. It was fine. Technically, it was a fine standard. Just you know, in the quirks of the in business, it just didn't succeed. So if you see 802.11a wireless networking devices, don't really worry about them because nobody really uses them, and so don't try to buy them either. If you see like 802.11a wireless equipment cheap, don't run out and buy it because you won't be able to use it on anything. A is not compatible with any other type of the networking. So G is compatible with B networks, N is compatible with G and B networks, B is compatible with B, G, and N networks. Nobody is compatible with A. It's not a backward compatible or forward compatible standard. So, like I say, A exists, but it kind of died. So if you see it, it was a fine standard that died. Don't really worry about it, unless you actually have it on your network. The next standard is 802.11b. This is a standard that came out probably about 10 years ago at this point. It's been a while. It was 11 megabits per second. It wasn't a bad wireless standard. It was pretty slow. You didn't have a lot of area, but you know, it wasn't bad for the first standard. So you have 802.11b, and that was 11 megabits per second. You then went up to 802.11g. That came out probably about 7 or 8 years ago at this point. That is up to 54 megabits per second and is a lot faster, a lot more stable than B wireless networks, and has been the standard now for, you know, since it came out, at least 6 or 7 years now. So, but B and G networks are compatible. So if you have a B wireless card, it can work on a G network. If you have a G wireless card, it can work on a B network. At this point, though, you shouldn't have B around. B is old. I mean, it's really old. It's something to know about, but if you have it on your network, if you're using it, just replace it. Throw it away and replace it, because at this point, it really is old. The new standard is 802.11n. This just got ratified very, very recently. They've had something called pre-N. So the process to get standards implemented, to get everybody to agree on a standard, can take a long time to happen. So a lot of companies come up with pre-standards. So what they do is they look at what the current draft of the standard is before it is actually accepted, and then they create their devices around that. So you will see there were a lot of devices out a few months ago that were pre-N devices. So what it was the N standard had not been ratified, so they created devices that were pretty similar to the draft. What you should remember, now that the N standard has been ratified, if you have these pre-N devices, they may act a little quirky on the network, because remember, they were created before the standard was finalized, before it was completed. So there might be some weird stuff in that pre-N device that you have, or that pre-N wireless access point, that doesn't make things on the network work well. If I were you, if I had the money and I had a pre-N device, I would probably try to get a new one, because you could get weird problems, like I say, because it was created to a standard, but the standard wasn't finished yet. And you know, if you're in the computer world, I think you understand what that means. Now, what is nice with the 802.11n standard is it allows for a much larger area to be covered by the wireless network. So 802.11n networks are twice as large as G networks. They're a lot faster than G networks. I don't know the exact number right now, but it's at least 2 times faster than G networks. And the best thing about 802.11n wireless networks is they allow for real-time video and voice communications. How wireless networks worked in the past, you would have a lot of problems with real-time communication, so like voice over IP, if you were using Skype or Google Talk or Yahoo Chat. If you tried to do that over a B or G wireless network, a lot of times you get into weird problems simply because how the technology was built. It was not built for real-time communications. 802.11n is built for real-time communications, and so that means we're probably going to get a lot of really cool wireless devices pretty soon. So what you should remember about wireless devices is you need the wireless access point. The wireless access point then allows all the devices to connect to the network. B, G, and N networking devices are all compatible with each other. A is not. Don't use A unless it's a legacy device that's on your system. Otherwise, don't even think about it. You know, if it comes up really cheap, don't worry about it. Then the B, G, and N. B is the slowest, G is better, N is the best, and it is available right now, and it gives you real-time voice and video communication. I want to take a moment to go into cabling. Most people don't think about cabling enough. They think of the cable that runs from their computer into the little jack in the wall, and then that's all they think about. They don't think about anything else. So I want to take a little field trip in my store and show you how the cabling is run and what that means for your network. So basically, you have the cable that runs from your computer. It then runs to the jack in the wall. That jack has a cable, maybe all the way up to 300 feet, that then runs through the wall and runs through your building all the way down to something called a patch panel. At the patch panel, you then have another connector, and that connector is what then gets plugged into the switch that we've talked about. So let's take a second and take a look around my store and show you what I'm talking about. Okay, so it's a little dark in here, but as you can see, this is the normal network plug that you would plug your computer into. So the cable goes from your computer and will go in here. Then as you see on the bottom, then there's cable that comes out, and this is what will run to the patch panel. Okay, so now from that connection upstairs, the cable runs down underneath the floor here. You can see all the cables, and you can see the cables coming together. Now here, you see all the cables from the rest of the building. So now we have about 15 cables that are all running down this one pipe and zip tied to it. Okay, so now here, we can see all the cables for the entire building come to this one area, and then they all get connected into the back of what is called the patch panel. So the patch panel is this device right here. all the cables get connected into it, and then you use something called a patch cable, so a cable that goes from the patch panel into the switch. So this is one of those big 48 port switches I was talking about. So this allows the computer upstairs to be connected into the port that's upstairs. That port has a cable that runs all the way down here, runs into this patch panel, and then from this patch panel you're able to make the connection into the switch. Now you may wonder why you use something like a patch panel, because it does cost money, you know, somebody has to install it, yada yada yada. What the patch panel allows you to do is, you know, you're going to be moving people around your building, or the people might be in one location next year when they're not there now. So what you can do is you can run cabling to all the places that you might need a wired connection. You can then connect those to the patch panel in your basement or wherever your server room is, but you don't actually have to connect them to the switch. So think about this. You could have in your building 200 network connections. So they're all run. If somebody needs a network connection, they can plug into it. But then you could have only a 48 port switch, because you would only connect the network cables that need to be live at the moment. So if your desk is here, then you would make sure that that port is live. That port is connected to the switch at the patch panel. Well, if you move your desk over here, you might use a different network connection, and then you would make that one live. You would take the connection that was used over here down in the basement or your server room, and then connect it to this other port on the patch panel. So that's why patch panels are used. It makes everything nice, neat, orderly, and you can run far more network connections than you're using at the moment. So like I say, is you can run 200 network cables throughout your building and only use one 48 port switch, because at any one moment you're not using 200 connections, you're only using 48. So if somebody moves, you can pull it out of the patch panel and move it around, but you don't have to buy 200 ports of a switch. That could get much more expensive. Now in this class, we've been talking about network devices. We've been talking about things like wireless access points, switches, routers, firewalls, modems. We haven't been talking about the normal computer stuff that you're used to, like, well, computers. In the networking world, everything that is on the network is called a networking device. So everything that's on the network, whether it's a router, whether it's a voice over IP phone, whether it's a computer, is a networking device. You will hear the term clients and servers. So in your business or your organization, you probably have a server. If nothing else, you have something called a file server. So you have one central computer that stores all the files that everybody accesses over the network. So all a server is it is a networked device that provides something to the rest of the network. So if you have a print server, this is a network device that allows other computers to print through it. So if you have a shared printer, then your computer is a print server. If you have shared files, then you have a file server. So all the server is it's a device that provides services to other computers on the networks. There is a difference, and you should just remember this, keep this in the back of your head. There's a difference between a server and a Windows server. So a server, again, is a device that provides services for the network, whatever it is. Any computer can be a server. A Windows 98 computer can be a server. A Windows XP computer can be a server. A Windows Small Business server is a server. Then there are Windows servers. Windows servers are a type of operating system that has been created by Microsoft. So these are very specific types of operating systems that provide very specific functions. That's off in its own little world. So a Windows server is a server, but that's not the only type of server that's out there. Basically, like I say, server is anything that provides services. Again, clients, then, are any devices on the network that get services from a server. So your computer that you sit at, if you send a print job to a printer that is shared on another computer, you are a client of that computer. If you access a file stored on another computer, you are a client of that computer. So the client is a computer or device that accesses something on another computer. That's all clients and servers and devices are, with what they mean. The one thing to remember though is server. There's servers in the computer world, and then there's servers in the Microsoft world, and they are two different critters. What you just remember, servers in the computer world are any computers or devices that provide services to the rest of the network. Servers in the Microsoft Windows world is a Microsoft Windows Server 2003, 2008 NT, and they do very specific things. So that was the introduction to networking class. We've gone over a lot of the networking devices, and I've tried to explain to you how they tie in so that computers and devices on your network can talk to each other and then go out and get to the internet. This is an introductory class. Coming out of this, you're not going to know everything. You're not going to be a master of networking. This just gives you the basis so that we can delve deeper into this subject in the future. We've gone over the basic concepts of speed, the difference between megabytes and megabits. 1 byte equals 8 bits. Keep that in mind. We've gone over what is logical and what is physical. So physical is the actual devices, it's the equipment that you pick up, and it's how things are physically connected. This cable goes to that box. Logical is how it all actually works. So many devices can be connected to one switch physically, but inside that switch, they may be logically divided up into different networks. So although they connect to one switch, they don't necessarily, are not able to communicate with each other. So we've talked about modems. They're the devices that connect your local network to the internet. We talked about routers. Routers are used to separate different networks. This is mainly used, like I say, in buildings with multiple tenants where they give you internet access. So in order to separate those tenants so they don't hack each other, they would have different routers, and that would separate the different networks out. We talked a little bit about firewalls, just a little bit, because firewalls are a big subject now. And like I say, they are no longer simply and only a networking device. Basically, firewalls protect your network from being hacked. Beyond that, it gets complicated. Either take another class here or learn more about it, because firewalls get really complicated. But they protect your network. You then have the switch. The switch is what all of your networking devices connect into. So every device connects into that switch, and then they can talk to each other. We talked a little bit about hubs. If you have a hub, throw it away because it is garbage. If you look at it, if you look at the device and it says hub, throw it in the trash. Simple. That's a troubleshooting technique. If it's a hub, throw it in the trash. Buy a switch. Switches, again, there's either managed or unmanaged switches. Unmanaged switches are completely and utterly automatic. There is nothing that you can do. There's nothing that you can do with it. You just plug it in and you hope it works. Managed switches, you can go in and you can program them to do certain things. Again, that gets complicated. That's another subject area, but you should know that some switches you can program to do certain things and other switches you can't. So either managed or unmanaged switch. We then talked about your wireless access points, how there's A, B, G, and N types of networks. N is the best and it's the newest. The best part about it is you can do real-time communications over it. So you can do voice over IP, you can use Skype, Google Chat, you can use digital surveillance systems. You can do a lot of things on an N network that you were not able to do before with BG networks. A networks were fine for their time, but it was not a standard that was ever picked up, so don't worry about A networks. B and G, they were good for their time, now they're gone. I showed you a little bit about cabling. So when you plug into that port in the wall, there's actually a cable that then runs all the way to wherever your server room is and plugs into the patch panel. The patch panel is, you then take a patch cord and plug in the port from the patch panel to the switch. The reason you do this is so you don't have to buy, a 300 port switch if you're only using 24 ports, because you can have more ports in your business or office space than you're actually using if you use the patch panel. We talked about clients, servers, and devices. So network devices is any device that is on the network, whether it's a router, whether it's a switch, whether it's an access point, whether it's an iPod, whether it's your computer, whether it's a network printer, that is a print device. Servers are any devices on the network that provide services to the rest of the network. So a printer can have a print server built into it, because if you plug a cable directly into the printer and then plug that into the wall, other computing devices on the network can connect to that and print. So a printer can be its own print device. Or you can have a printer plugged in to a computer, and you can have that computer share the printer, and that's how the printer is now shared. So the computer is the print server, because the computer is allowing access to that printer. Clients. Clients are simply computers on the network that use a service from some server on the network, whether they're using a shared file somewhere, whether they're printing to a shared printer, or whatever. A client uses a service provided by somebody else. Servers, there's server, like the big server name. So servers in the computing world, again, are any computers that provide services to other computers on the network. Then there's the Windows server. Microsoft Windows servers are specific types of operating systems that do very specific things. So just remember, servers are any computers on the network that provide service, and then there's Microsoft Windows servers that are their own little kettle of fish. So that's the class on this. I hope you understand what's going on. The big thing to remember now is all of these different devices we talked about. We talked about routers, we talked about firewalls, we talked about switches, we talked about VPN endpoints. Again, that's logically how it works. Now the devices that you buy have all these logical devices built into them physically. So this router here is a router, it's a firewall, it's a VPN endpoint, it's a switch. You can connect up to 4 different computers or networking devices to it. So this one physical device serves multiple logical functions. So just keep that in mind. So don't, like I say, don't go out to the store and try to look for a standalone firewall. You probably won't find it. All the devices are now normally built in to one physical device. So again, I'm Eli the Computer Guy. This was Introduction to Networking, and we'll see you at the next class.